So today we're going to go ahead and talk about it. So let's imagine that I have a pendulum where here is some mass of mass m. We'll just say yes to that. Okay, cool. And it is rotating back and forth. So I'm going to go ahead and draw it on a couple points. So imagine that I'm holding this pendulum vertically. Cool. And let's say it's going from left to right and back and forth, vice versa. Cool. So a couple points I want to talk about. These points right here that I highlighted in red are called the turning points, just because this is where it changes direction. And so what I want you all to think about, what is the velocity of something at the turning point? Well, we know if we throw a ball vertically just straight up in the air, its velocity is 0 for a split second as it changes direction. Same thing has to happen in this place. If we're going from, let's say, a positive velocity to negative, velocity has to be 0 for a split second. So velocity is 0. Cool. Let's think about what type of energy the object has at different points. So again, let's say I say that this is our line for our height to be 0. So we know, like, when an object is right here, at some distance above that, it is going to have gravitational potential energy, no kinetic energy because it's at rest. So again, UC at those points. Let's look at the bottom point. So at the bottom point, that's where the height's 0. It's no UG. That is going to be all KE. So that is where the object is going to be moving fastest. While if we look at these other 2 points, the object is moving, but it is also some height above the ground, so it has both UG and KE. Awesome. So now that we've done that, let's go ahead and solve a problem together. So what I want to look at is this problem below, and I'm going to just scroll. I'm just going to erase this just so I have a little bit more space right there. Okay, cool. Okay, so let's go ahead and look at this problem. So we have the problem below. We have a pendulum of mass m suspended at the end of a cord of length, and it should be just L. Ignore that little m. Okay, so this cord is length L. I'll put that on there. The pendulum is released at an angle of 30 degrees with the vertical and release. So right here, that's 30 degrees with the vertical. We want the speed of the pendulum at the lowest point of its swing. Your answer should only include ml and any fundamental constant. So a fundamental constant is something like g, acceleration due to gravity. Cool. So I'm going to go ahead and draw it at its lowest point. So we're going to follow our good old conservation of energy recipe, which I have to the right. So we will first draw a picture, which we just did. Then we're going to go ahead and pick a reference point where UG is 0. So a good point always for that is going to be just here, that the height is 0 at this like base right here. Cool. And I should have labeled on here, we want the speed at the lowest point in swing. So we want the velocity right here. Cool. So we went ahead and did that. Now let's look at 2 positions, 1 and 2, at which we either have some information or desire some information. So we know that the object is starting right here, and it goes to here. So those are going to be our 2 positions. So that is our 2 positions. Now let's go ahead and do step 4. Let's label the type of energy at each position. Okay. So right here, we know right here, it starts off at rest. The velocity is 0. So we know if the velocity is 0, there's no kinetic energy. It is some height h above the ground. So it is going to have UG, or I should say not above the ground, above what we say the height is equals 0, reference point is. Okay, so now let's look at this bottom point. That is at height h equals 0, so there's no gravitational potential energy, but there is kinetic energy here. Cool. We're not dealing with spring potential energy because there's no spring potential energy at all. Cool, so we did step 4. Now let's use conservation of energy. So let's say the energy at 1 equals the energy at 2. And we know at 1 it is all UG, and energy at 2 is all KE. Cool. So now let's go ahead, solve for unknowns, and go ahead and plug in our equations. So our UG equation is mgh, our KE is 1/2 mv squared. Cool. Let's see what we can plug in or simplify. So mass is on both sides. Everything's just multiplied together. I can divide both sides by m. So m cancels out. So we're left with gh equals 1/2 v squared. Okay, so we are solving for velocity. I'm going to go ahead and solve for velocity. So this will be 2gh, bring that 2 to the other side, and then I can take the square root for velocity. Cool. So let's look at to see what we're allowed in our final answer. So only n, l, and any fundamental constants. Okay, so we didn't need m at all. G is allowed in there. H we don't have. So let's see how we can put H in there somehow. Okay, so, oh, H is not allowed. Okay, so what can we substitute in for H? So let's go ahead and look at this picture. So this is the height H we need. I'm going to go ahead and move this KE thing just so I have a little more space to write. Okay, so let's see what we can use. So we know this whole entire length right there is L. So if it's a pendulum and it's swinging back and forth, this whole length right here we know is going to be L. Okay, so that whole length is L. So now let's see what we can do. I'm going to go ahead and we essentially just want this length right here to be H. So we're going to need to essentially know this whole entire distance. So if we set up a good old triangle, so this is 30 degrees and this is L, we want to find this side right here, which is the same as this side right here. That's going to be L cosine of 30 degrees. And we know cosine of 30 degrees is root 3 over 2. So that is going to be L root 3 over 2. So we know this is L root 3 over 2. So now let's look at this. We know this whole entire length is L. And we know this is L root 3 over 2. So a little bit less than L. So now we can solve for this last missing distance, which is just going to be like essentially L minus H, or sorry, oh my goodness, L minus this distance right up here, which is L root 3 over 2 is going to be H. Cool. So this we can now plug in is 2G times L minus L root 3 over 2 is going to be V. And we got our final answer. And again, that's using from up here, we knew that whole thing was L. So then we did, and we wanted this little distance right here, H. Awesome. Thanks so much for watching.